In 2003, there was some work looking at pastiche, meaning the attempt to imitate famous authors in order to capitalize on their success and write more books. In this case, they looked at Alice in Wonderland and imitators of Lewis Carroll. And they had kind of mixed results in figuring out who authored the unknown documents. And there's some other work on automatically obfuscating document stylometry in order to preserve anonymity, where they figured out how many words they needed to change in order to get it to be recognized as someone else. Now, this seems kind of similar to the work we did, but they really are just looking at modifying a document in small, particular ways, whereas we're trying to assess the general vulnerability of authorship recognition against inexperienced human adversaries, which is kind of the hopefully realistic scenario here. So there's two attacks that we looked at. The first is an obfuscation attack. This is where you're simply trying to hide your writing style. It doesn't matter who is attributed authorship of this document. It doesn't matter. That doesn't matter at all. You're just trying to make sure it doesn't come back to you. The second attack is an imitation attack, where you're trying to specifically imitate the writing style of another author. This can be used, for framing purposes, things of that nature. Our study setup was to pick 3 representative methods of stylometry and test them all against the same data set. We had 15 authors. We had them first submit about 5,000 words of pre-existing writing that has not been modified from some sort of formal source, like a school essay, a work report, things like that. And then we had them write 2 attack passages. First, they wrote an obfuscation attack describing their neighborhood. We wanted everyone to write the same content in order to try and get rid of any sort of intricacies that might give away authorship that aren't based on the writing style. And then the second passage, the imitation attack, was to imitate Cormac McCarthy. He wrote a book, The Road, recently that some of you may have read, and try and imitate his writing to describe their day in the third person. It's important to note that these authors had no formal training in stylometry, no formal training in linguistics, and only spent about 30 to 40 minutes overall on submitting all this information. Well, mostly on the attacks. They might have spent more collecting their old documents, but spent no more than 30 or 40 minutes on these attacks. I want to go into a little more detail about imitating Cormac McCarthy because we thought this was kind of an interesting result. So as you can see from this quote, he has a very distinct writing style with some interesting word choices, saying things like the stark black burn or charred and limbless trunks. He writes in kind of shorter sentences, things like that. And we actually have some example imitation attacks from people trying to imitate Cormac McCarthy. And you can see without any direction on what stylometry is or how it can be used to detect writing style, people did adapt to his writing style. They picked some more descriptive language. And keep in mind, it was kind of funny to read these passages because they were suddenly describing their day when they woke up as opposed to describing a post-apocalyptic wasteland. So this kind of shows, some examples there. And so now I want to go over the 3 methods that we evaluated. First, we did a validation experiment where we looked at the original 3 methods and tried to determine the accuracy of them and make sure it was as accurate as the authors of the original methods claimed they were. And then we did the attack experiment where we determined the accuracy of these attacks against these methods. The experimental conditions were to have a set of 15 authors but extract sets of 2, 3, 4, and 5 authors from that overall set. And the same sets were used in each method. And then we cross-validated all the results to try and get the most accurate numbers possible. Before I go into what the methods were, I just want to give a brief overview on what machine learning is. So machine learning is artificial intelligence. The idea behind it is to learn and recognize patterns automatically from some sort of information that is extracted from the text, and then or whatever it is you're studying, and then make decisions based on that. So the most common form of machine learning is a classifier. Anyone that's familiar with spam filters, which I imagine all of you are, your spam filter is probably a Bayesian classifier. It looks at the words in the email. It determines the probability of whether or not that email is spam based on the occurrence of certain words, and adjusts those probabilities as the system gets trained on more spam messages. The extracted features I talk about, features are just pieces of information in whatever you're trying to classify. So in the spam case, they are generally words. The features are words and how often those words appear in spam messages and how often they appear in non-spam messages. So it's important to pick good features, and you'll see in each of these methods, different features are used. Some basic linguistic features that we used here are things like word counts, sentence counts, letter distribution, punctuation, and then we use some more complicated measurements like lexical density, which looks at how many unique words there are compared to how many total words there are, and some readability indexes that look at sentence length, the complex word ratio, where a complex word is a word of 3 syllables or more, excluding lots of common words. Then the Gunning-Fogg readability index in particular gives you some idea on the reading level that is required to read a document. The first method we looked at was the signature stylometric system. This is not one that we coded, but rather kind of an out-of-the-box system that you can find if you search for signature stylometry. And we found that it had a 95% base accuracy on the unmodified base data set. The second method we looked at was a neural network classifier based on 9 specific linguistic features. And we had almost 80%, about 78.5% base accuracy. Just a note, a neural network is a simulation of a biological neural network where you have a set of input nodes and a set of output nodes. The input nodes indicate the features, the output nodes indicate the possible classes, which in this case are authors, and the hidden nodes are modified accordingly in order to get the best classifier possible. And these are all arranged during the training phase of a neural network classifier. So you train it on a bunch of known data, and then you give it some unknown data and see what the results are. There we go. Okay. The third method is a synonym-based classifier that didn't look at the linguistic features so much as the word choices, which is a linguistic feature. And we had 88 to 99% accuracy, depending on how many authors there were. Here's actually a pretty example of how this works. So you'll see the top and the bottom are known documents. The first sentence is colorless green dreams sleep furiously, and the bottom sentence is bright verdant grass sways peacefully. And this unknown sentence is colorful, verdant dreams sleep furiously. So there are more words in common with the top sentence than the bottom sentence, but that unknown sentence is actually attributed to this last author because verdant has many more synonyms available to use, so it's a more salient feature. And therefore, the overall point value lends that sentence being attributed to the last author as opposed to the first author. This is a pretty neat technique, and we thought it would be good to take techniques that dealt with different parts of linguistics. So here's the accuracy on the original training set. You can see the 3 different methods. This black line here represents random chance. So what would your accuracy be if you just randomly selected and randomly picked what author it could be? So all of them are much higher than random chance. Most of them hover around 80 to 90%, in some cases going up near 100%. When we introduced the obfuscation attacks, however, the accuracy went way down. It went down to just about random chance. So these same methods that had anywhere from 70 to 100% accuracy in unmodified text, when they tried to detect the authorship of the attack passages, the modified obfuscated text, they did no better than random chance. Interestingly, when we introduced the imitation attacks, the results went even lower, down to almost 0 in most cases. This might sound interesting because you think, well, how come the subjects weren't as good at imitating, how come the authors weren't as good at obfuscating their own style as they were at imitating someone else's? And we thought this is probably because when you're imitating someone's style, you're given some more direction on how to change your style, and we ended up with these results. Furthermore, when people tried to imitate Cormac McCarthy, these graphs here show the success rate in actually imitating Cormac McCarthy. So 60 to 90% of the cases in general, people were able to successfully imitate Cormac McCarthy and his writing style and have these systems think that they were in fact Cormac McCarthy. There's some interesting discussion points to bring up based on this. One is